Hey guys, so today we're going to see problem number 240 in LeetCode. It is such a 2D matrix 2 problem. It is actually an easy problem. So the description says write an efficient algorithm that searches for value in an m and 2n cross matrix. Okay, this matrix is the following properties: integers in each row are sorted in ascending from left to right, and integers in each column are sorted in ascending from top to bottom. Example, consider the matrix 1 4 7 11 15. So if you see 1 4 7 11 15, this row is sorted in ascending from left to right, and same is the case with every other row. All rows are sorted from left to right. And if you go to the first column, even that is also sorted from top to bottom. Second column is also sorted top to bottom. So given target equal to 5, 5 is here. Okay, so it is going, you should return true. And given target equal to 20, 20 is not present anywhere, so it should return false. So this is a very famous search space reduction problem. So this is because you are given that the matrix is sorted. It is sorted row-wise as well as it is sorted column-wise. Okay, so how can we make use of this problem? So if you fix your axis at one particular point, and if you try to expand your space, search space, okay, and if you're encountering your value, it's fine. And then if you're not encountering a value, meaning that your value is either less or it is greater, then you try to either reduce your search space or you try to increase your search space. So when you say increase your search space, this means you will be exploring other rows. And then when you reduce the search space, which means that you will reduce the number of columns that you're going to explore. What am I saying? So for example, let's take a simple matrix. So let's say 1 2 3 4 5 6 7 8 9. So this is a matrix which is sorted both in the row wise as well as in the column wise, right? So suppose if I fix my starting point as the last element in the first row. Okay, so basically this is a 3 cross 3 matrix. So let's say my start is going to be 0th row, and end is the last element in the first row, which means it is column is 2. Okay, so what I'm going to do is we are going to start from this position and try finding whether we're able to figure out which search space to look out for our target element. Let's say our target element is 5. Now at start is equal to 0 and end is equal to 2. Is matrix of 0 2, is this equal to 5? No, it's not. It is actually 3. So actually 3 is less than 5. So we have encountered an element which is less than 5. So what you can do is in the current row we have encountered an element which is less than 5. So what if we go explore the other rows? So what we're going to do is we'll increment the row. So in the current row we are not able to figure out whether 3 is present and whether 5 is present, so we'll increment row, which means it will become row is equal to 1. Okay, column remains the same. So basically it is start becomes 1 because we're exploring the second row. Okay, so in this case matrix of start and end, so start is now 1 and we see 2 is the same thing, right? So we see 1 comma 2, is this equal to 5, a target element? No, it is actually greater. 6 is actually greater than 5. So this means then we have to look in the same row, but then we have to move forward. So which means we have to reduce the column. Okay, so in this case we will reduce the end pointer, which is previously 2, now it will become 1. So now we have to check the matrix of 1 and 1 if this is equal to 5. Of course it is. So then we will return true. Okay, I hope it was clear. So let's code it. Okay, and if possible, I'll explain the same thing at the end also. So let's do the null check, sanity check. So matrix equal to null, or matrix dot length. If this is equal to 0, then this means we cannot find any element in this matrix. So we're going to return false. So otherwise, let's fix our starting point for exploration. So start is going to be 0, and end is going to be matrix of 0 dot length minus 1. Okay, now while start, we are starting from 0, so it should be less than matrix dot length. So until we explore the last row, and end, we have started from the last column, so we'll go until the first column. Okay, so if this is not true, then we'll obviously come at the last and we'll return false. So here what we're going to do is we are just checking. So we started from 3, right? So here is 0, and in this matrix, number of columns minus 1 is going to be n, which is 2. So initially we started with start is equal to 2 and end is start is equal to 0 and end is equal to 2. So what we're doing is we'll check if matrix with start end, if this is equal to target. If this is the case, then we're just going to return true. We have found this target. Okay. If not, we are just checking if matrix of start end, if this is less than target, right? Our case. Like here we saw 3 and 3 was less than target. So what did we do? We moved to the next row. So which means we'll increment start. And the other case where it was not less than, that case we have encountered an element which is greater than the target, so we will keep looking in the same row but then in the previous column, so we will reduce n minus minus. Okay, that's it. So let's take another example. So for example, let's say I have to find the element 10. 10 is a number which is not here in the subspace matrix. So initially we'll start from 0 2, and then we see that it is 3 is lesser than 10. Yeah, and so what we do is we increment the column and the row, and then we will come here, and then here we'll check whether 1 and 2, if this is equal to 10. Obviously 6 is lesser than 10, so we will increment or start, right? So start will be incremented, so start will become 2 and end is remaining the same, which is 2. Okay, start is 2 and end is 2, and then we see whether 2 2, if this is equal to 10. It is not, so in this case 2 2 is actually less than this, so we have to increment start, and start is will become 3, which is actually greater than the number of rows, so we will come out and we will return false. Okay, so let's see another example. Let's see that we have to search for an element 7. So let's say target is 7. So initially we'll start from this position. Start is equal to 0 and end is equal to 2. Is 0 2 equal to 7? No, because 3 is lesser than 7. So which means we'll increment start. So start will become 1. We'll see 1 comma 2 if this is equal to 7. So actually 6 is less than 7. So we will again increment start, and we will see whether start of 2 comma 2, this is equal to 7. Actually 2 comma 2 is 9, right? And 9 is greater than 7, so which means we have to decrease end, right? It is greater than, if it is greater than 7, we'll decrement n. So n becomes 1. So we see whether 2 comma 1, so matrix of 2 and matrix of 1, if this is equal to 7, actually 8 is greater than 7, which means we have to reduce n's again, so n becomes 0. Now we see matrix of 2 and 0, if this is equal to 7. Yes, of course it is, so we will return true. Okay, I hope it was clear. This is what programmatically we have coded at the top. So when you observe the time complexity, right, we are starting from 0 and then we are going until we have exhausted column or row. So at the max, if it is a square matrix at the max, it is going to be O of, again, where n refers to the number of columns or number of rows in a square matrix. And if at all of it is a two-dimensional matrix, it is not a square matrix, then it is obviously going to be n plus 1, as long as we are not exhausting any rows or we're not exhausting any columns. We'll proceed until the direction. So it is going to be the maximum O of n plus. Yeah. And when it comes to space complexity, not obviously using any extra space, so it is going to be O of 1. Okay, let's quickly run this code. It's accepted. Let's submit this. And it is a successful submission. So that's it, guys. I hope it was very clear. Thanks, guys. Bye.